Good day, fellows. Setso is back. Today, my fellow learners, we are going to do the new concept of electron configuration. Electron configuration. By definition, the term electron configuration simply implies the arrangement of electrons in the nucleus of an atom. You see, it's the arrangement of what? Of electrons in the nucleus of an atom. If I can even continue with this topic, firstly, we must know on how to calculate the number of electrons. We use this formula, which is electrons is equals to atomic number subtract what? A charge. We use this formula to calculate the number of electrons. And again, another thing that we must know as learners is we have different energy levels. We will have first energy level with a subshell of S. We also have the second energy level with subshell S and P. Also third energy level with S, P, and D. As learners, we must know that the subshell S can take a maximum of 2 electrons. Then P can take up to 6. Lastly, D can take up to 10 electrons. Then at this point now, what I'm going to do is I'm going to give you a neutral element, which is an A11 together with 23. Its atomic mass. We have a sodium with an atomic number of 11 there. Atomic number also has an atomic mass there. Then let's say they ask us to write the electron configuration. There are two methods: spectroscopic notation as well as noble gas notation. Firstly, I'm going to start with spectroscopic notation. You see the electron configuration using a spectroscopic notation. Then how then are we going to approach this question? Firstly, we must determine the number of electrons using this formula. We are going to say now the number of electrons equal to the atomic number, which is 11, subtract a charge. This is a neutral element. You see, we don't have any charge there. Then we are going to write 0. When we subtract, we get 11. Then this number represents the number of what? Of electrons. At this point, we are then going to follow these arrows in order for us to represent those electrons in a spectroscopic notation. You see, firstly, I'm going to start from this arrow, which is 1s. Going to say 1s. You see, s can take up to 2 number of electrons. You see, then I move to the second one, which is only 2s. 2s can take also up to 2 electron. Then let us move to the third one, which is 2p as well as 3s. I write 2p, which can take up to 6. Lastly, you follow this arrow is 3s. 3s. At this point from here to here, if I add those numbers, I get 10. I only need 1, not 2. This can take up to 2, but I only need 1 electron because they are 11. Then at this point, I have now answered the question of spectroscopic notation. Using spectroscopic notation, we also have another notation, which is a noble gas notation. Then now, how are we going to approach this question for a noble gas notation? It's so simple. Do you still remember? I also have a periodic table. Do you still remember all the elements in group 18? Those are the noble gas. You see? Those are the noble gas. We are going to use our spectroscopic notation to answer this question of noble gas notation. So simple. Check. We have so far helium and neon. You see? Let me take these two. But for us to answer this question, we are going to consider the possible maximum noble gas that can be found from this spectroscopic notation. The highest possible noble gas is going to be neon, which is 10. See, from here till here, if we add those numbers, we get 10. Then the corresponding noble gas is going to be Ne, which is neon. Somehow we are going to replace this from here till here with what? With neon. Then add that last 3 as 1. You see, at this point I have answered what? The question of noble gas notation. You see, that's how we answer this question.